Boiler classification by structural design. Besides being classified by fuel type and combustion technology, boilers can also be classified by their structural design. Before we get into this topic, let us first understand a few basic terms. The first term is the water tube. A water tube is a steam-generating tube in which water flows inside the tube, while hot flue gas flows around the outside. Heat from the flue gas passes through the tube wall, heating the water inside and producing steam. The second term is the fire tube. A fire tube is a steam-generating tube in which hot flue gas flows inside the tube, while water surrounds the outside. Heat from the hot gas inside the tube passes through the tube wall to the surrounding water, generating steam. The third term is the furnace tube. A furnace tube is the large tubular combustion chamber inside a fire tube boiler. This is where the fuel burns inside the tube, while the surrounding water absorbs the heat. The fourth term is the steam drum, sometimes simply called the drum. A steam drum is a large cylindrical vessel that contains both water and steam, or only water, depending on the boiler design. The drum separates steam from water, stores a certain amount of steam, and helps stabilize the steam supply. The fifth term is the single drum boiler. A single drum boiler has one drum that contains both water and steam. The sixth term is the two-drum boiler. This boiler design features a lower water drum and an upper steam drum. The lower drum mainly contains water, while the upper drum contains both water and steam. The eighth term is radiant heat transfer. Radiant heat transfer occurs when a heat transfer surface receives heat directly from the flame and the high-temperature combustion zone. You can think of it like standing near a fire. Even without touching the flame, you can still feel the heat. That is radiant heat transfer. The ninth term is convective heat transfer. Convective heat transfer occurs when hot flue gas flows directly across a heat transfer surface, transferring heat to the surface and then to the water. Both radiant and convective heat transfer always take place inside a boiler. The difference is that in each area of the boiler, one form of heat transfer may play a greater role than the other. Let's take a look at some of the most common boiler designs. Today, there are many different boiler designs available on the market. In this video, we'll focus on the three most common structural designs used in industrial saturated steam boilers. The first is the combined water tube and fire tube boiler with a single steam drum. The second is the two-drum water tube boiler. The third is the single-drum water tube boiler. Let's look at each design one by one. First, the combined water tube and fire tube boiler with a single steam drum. This type of boiler has a radiant furnace surrounded by water tubes. The rear convection section uses fire tubes. In the furnace section, water flows inside the tubes, while the hot gases and flame flow around the outside. In the rear section, the hot flue gas flows inside the fire tubes, while water surrounds them on the outside. That's why this design is known as a combined water tube and fire tube boiler. Next is the two-drum water tube boiler. In this design, the furnace walls are formed entirely by water tubes, which absorb radiant heat and generate steam. The convective heat transfer section is also made entirely of water tubes. These water tubes connect the upper and lower drums. The lower drum mainly contains water. The upper drum contains both water and steam. Water circulates through the tubes, absorbs heat from the hot flue gas, and turns into steam. The steam is then separated in the upper drum before being supplied to the steam system. Finally, the single-drum water tube boiler. Like the previous design, the furnace is enclosed by water tubes that absorb radiant heat and generate steam. The convective heat transfer section is also built entirely with water tubes. However, this design uses only one upper drum, which contains both water and steam. Water flows from the drum into the generating tubes, where it absorbs heat and becomes a steam-water mixture. The mixture then returns to the drum, where the steam is separated from the water. Because it contains less water, this boiler can generate steam more quickly and usually has a shorter startup time. Now let's take a look at the main advantages and limitations of each boiler design. I'd like to make one thing clear. Every boiler design has its own strengths and limitations. There is no single design that is the best for every application. The most important thing is selecting the right boiler for your application, considering your steam demand, fuel type, operating pressure, boiler capacity, required steam quality, operating requirements, maintenance needs, and investment budget. In a combined water tube and fire tube boiler, the steam drum is not directly exposed to the flame. This type of boiler is commonly designed for capacities of up to about 20 tons of steam per hour. Its typical design pressure is generally up to around 16 bar. For higher pressure applications, material and manufacturing costs increase significantly, making this design less economical than some other boiler types. One of its biggest advantages is its excellent heat transfer efficiency. That's because the flue gas flows through many small fire tubes. As the flue gas is divided into many smaller streams, the contact area between the hot gas and the heat transfer surface becomes much larger. This results in highly efficient heat transfer. Another feature of this design is its relatively large water storage volume, thanks to its large steam drum. The larger water volume means a longer startup time, because more energy is required to heat the water before steam can be produced. However, once the boiler reaches stable operation, it can maintain steam pressure more steadily, even when the steam load changes. Another advantage is that it can produce drier steam when the steam space is properly designed. Because the steam space is larger, steam velocity above the water surface is lower, reducing the chance of water droplets being carried into the steam line. As a result, this design generally provides better steam quality for applications that require stable dry steam. However, it also has some limitations. Since the flue gas flows inside the fire tubes, ash and dust can easily accumulate on the inner tube surfaces. When burning biomass or coal with high ash content, the fire tubes need to be cleaned more frequently. If cleaning is neglected, ash deposits restrict flue gas flow, reduce heat transfer, increase stack temperature, raise fuel consumption, and reduce steam generation efficiency. On the other hand, cleaning fire tubes is relatively simple and straightforward. By opening the inspection doors, each fire tube can be cleaned individually. If a fire tube becomes damaged, replacing an individual tube is generally easier than in many water tube boiler designs. This is a very practical advantage when it comes to maintenance and repair. Next, let's look at the two-drum water tube boiler. Compared with the combined water tube and fire tube design, a two-drum water tube boiler contains less water. Because it holds less water, it can produce steam much faster during startup. This is a significant advantage for plants that require fast startup or frequently experience changing steam loads. The lower drum also provides a place where sludge and some solid deposits can settle, helping reduce the amount of debris entering the generating tubes. However, it's important to understand that not all scale and deposits remain in the lower drum. If water treatment is inadequate, blowdown is not performed properly, boiler TDS becomes too high, or the feed water quality does not meet specifications, scale can still form inside the water tubes, especially in areas with high heat transfer. So even with a two-drum water tube boiler, proper water treatment, correct blowdown practices, and regular scale inspections are still essential. In terms of steam generation speed, this design has an advantage over the combined water tube and fire tube boiler. However, when it comes to steam dryness, a two-drum water tube boiler may produce wetter steam if an effective moisture separation system is not incorporated into the design. That's because the upper steam drum is usually smaller, providing less steam space. During rapid load changes, water droplets are more likely to be carried into the steam flow. Fortunately, this issue can be effectively addressed through proper boiler design. For example, the steam drum can be equipped with baffles or moisture separators, the steam outlet can be properly positioned, and an additional steam separator can be installed in the main steam line to further improve steam dryness. So steam quality depends not only on the boiler type, but also on the manufacturer's engineering and design details. Another practical limitation is that repairing or replacing individual water tubes is generally more difficult than replacing fire tubes. In a fire tube boiler, a damaged tube is usually easier to access and replace. In a two-drum water tube boiler, if a generating tube in the convection bank becomes damaged, a common emergency repair is to isolate that tube by plugging both ends. If only one or two tubes are affected, this temporary solution may be acceptable under certain operating conditions. However, if too many tubes are plugged, the available heat transfer surface is reduced, resulting in lower boiler capacity and reduced efficiency. Of course, if sufficient shutdown time is available, the damaged tube bank can be completely replaced. But when it comes to fast emergency repairs, the two-drum water tube boiler is generally less convenient than the combined water tube and fire tube design. Finally, let's look at the single-drum water tube boiler. Among the three designs we've discussed, the single-drum water tube boiler contains the least amount of water. Because of its lower water volume, it offers the fastest steam generation. It also has the shortest startup time. This makes it an excellent choice for applications where the steam load changes rapidly. Another advantage is that the water tube arrangement can be designed to provide easy access for cleaning, allowing the heat transfer surfaces to be cleaned efficiently. With properly designed access openings, individual tubes can also be replaced when necessary. Although the process may be slightly more difficult than with a combined fire tube design, tube replacement is still practical. However, because this design contains less water and often uses inclined tubes or closely arranged convection tube banks, it is more sensitive to poor water treatment. If water quality is not properly controlled, scale can form more easily inside the convection tubes. When scale builds up inside the water tubes, heat transfer from the flue gas to the water becomes less efficient. This can lead to localized overheating, which may eventually cause tube swelling, cracking, or tube leaks. For this reason, single-drum water tube boilers require stricter water treatment, proper blowdown practices, and closer water quality control. To summarize, if fast steam generation is your priority, the single-drum water tube boiler has a clear advantage. With a well-designed layout, cleaning can also be completed quickly, reducing boiler downtime. However, when operating conditions are poor, water treatment is inadequate, or blowdown is not performed regularly, this design is generally less tolerant than a combined water tube and fire tube boiler. To summarize what we've discussed so far, here's a quick recap. The combined water tube and fire tube boiler offers excellent heat transfer efficiency, a large water reserve, more stable steam quality, easier cleaning, and simpler fire tube replacement. Its limitations include a longer startup time, more frequent ash buildup inside the fire tubes, and lower suitability for very high pressures or very large capacities. The two-drum water tube boiler generates steam more quickly and is better suited for certain pressure and capacity ranges. However, achieving high steam dryness depends on effective moisture separation, and tube repairs are generally more difficult. The single-drum water tube boiler offers fast steam generation, a compact design, and quick maintenance when properly designed, but it is also more sensitive to scale buildup inside the water tubes. For all these boiler designs, poor water treatment chemical control, irregular blowdown, or failure to check for scale buildup regularly can create a high risk of boiler damage. In terms of tolerance to less than ideal operating conditions, fire tube boilers generally provide the greatest margin for error. Two-drum water tube boilers are less forgiving, while single-drum water tube boilers are typically the most sensitive. Differences in steam quality between boiler designs can also be addressed through proper design solutions. Therefore, the question is not which boiler design is absolutely the best, but which one best suits your needs and whether it is properly designed, manufactured, and operated. Understanding this point is essential before making any boiler purchasing decision. Don't focus only on the price or the boiler capacity. Ask whether the boiler design matches your steam demand, your fuel, your operating and maintenance requirements, your environmental goals, your fuel efficiency targets, your maintenance strategy, and your expected service life. That's the right approach when investing in an industrial boiler. We hope you found this video helpful. Thank you for watching, and we'll see you again in our next video. Thank you.